This conference will now be recorded.
So, in the previous session, we discussed about different types of performance testing. In the initial demo session, we had an agenda like what is performance testing, LoadRunner architecture, sample record and replay, and all that stuff. So, in yesterday's session, we covered what are the different types of performance testing. So, we covered load test, stress test, endurance test, scalability test, volume test, and spike test. We didn't cover failover test. We'll look into that today. But before going there, let's try to understand some other concepts like what is the importance of software architecture. Okay, so generally, one more important thing. Uh, so whenever I click a link or click a button on the page or click a link on the page or whenever the page refreshes or whenever a user clicks a button and navigates from one page to another page, as per the industry standard, how much time it should take maximum? Can anyone tell how much time it should take maximum as per the industry standard to load a page completely or to navigate from one page to another page?
2 seconds, less than 2 seconds.
Yeah. So it is like less than 2 seconds is the industry standard. However, depending on the project architecture, depending on the project complexity and all, there might be some exceptions given by the client. So the client will be okay if it is like 3 or 5 seconds as well. It all depends on client and requirement. Okay. But industry standard is just 2 seconds. Okay. Now let's say you have this page or like let's say login functionality page where you need to enter username, password and click on submit button. Okay. User entered the name and password and clicked on submit button. So what should happen when the user clicks on submit button? It should navigate to home page, correct? Now it is navigating to home page, but let's say it is taking like 60 or 60 seconds or 40 seconds, something like that. Now, is it okay if it is taking 60 seconds or 40 seconds? No, because industry standard is 2 seconds, like plus or minus something one or two is fine, but at least 30 seconds, 40 seconds, 1 minute is too much, right? So what if this process is slow? Okay. So what if this process is slow? Like you entered username, you entered password, you clicked on submit button. Now it is taking too much time to go to home page. What if the process is slow? Reason could be an issue with the application, correct? Reason should be an issue with the application. Now whatever the issues, okay, because of which this login process is slow is called bottleneck. In simple terms, in performance testing terminology, we call it as bottleneck rather than issues. Okay. Now, as a performance tester, we need to know what is exactly happening when I enter username and password and click on submit button. So when I click on submit button, what is the action that is getting performed in the backend? Where which request is being sent? Okay, to which component? What exactly is happening in the backend? Why is it taking 30 seconds, 40 seconds like that? So if you want to know what exactly is happening in the backend, then you need to understand the project architecture. Okay. So without understanding the architecture of your software application, it is difficult to find the root cause. Okay. So to find out the root causes related to performance, definitely we need to understand the architecture. Okay. In this case, we need to know what exactly is happening when you click on submit button. Okay. So any questions still here? Everyone are clear with this? Okay. Now, uh, let's go to the next slide. So in this slide, we are discussing one important term called server. So in performance testing, uh, day-to-day job or day-to-day activities, every now and then we keep on using this term server. Okay. So server is a common word that we use in our day-to-day work. So what exactly is this server? So basically, server is something which is which can accept your request by understanding it, which can process your request, okay, and then send the response back. So here, let's say this is client from where the request is going. This is server. So you're sending a request to server, and the server is sending the response. So this is a server. Okay, this should understand what the client is sending, and then it should process your request, and then it should send the response back. So anything, okay, any software program with the combination of hardware also, anything that can understand your request, process your request, and send the response back is called a server. So software alone cannot run on its own, right? It
Auntie,
need Software alone cannot run on its own, right? It needs some hardware support. It needs some hardware support. Okay, it needs some hardware support. So that's the reason, you see, both. Uh, but software alone cannot run on its own, and it needs some hardware support. So combination of both is called server. Okay. So uh, if in general, if someone is asking you what is a server, you can say like it could be a software program along with hardware, including hardware, which can understand your request, process your request, and then send the response back. Okay. So that is called server. Now let's try and understand what is the software architecture, generally how it will be. Okay, nowadays how the architecture is, now how nowadays how the architecture is, how the architecture is being selected or used in your projects. Okay. um, so let's say the most likely, the architecture would be something like this. Most likely the architecture would be something like this. So what is the first one? Web server, app server, and database server. What is web server? What is web server? So when you send a request from client, when you send a request from client, okay, when you send a request from client, one second, okay, when you send a request from client, it will go to web server. What type of request will go to web server? What type of request will go to web server? HTTP or HTTPS request might go to web server. Okay, HTTP or HTTPS request might go to web server. Now, what exactly is this web server? A web server is something which will host a website, right? Which will host a website. What is a website? What is a website? A website is nothing but a collection of web pages, right? A collection of web pages. Now, every application, whenever you send the initial request, that will go to the web server. What can anyone tell me the examples of web server? Any one example of web server? Anyone? Any example
Apache
of web server?
Tomcat JBoss,
Sorry? Yeah, you can say like Tomcat, Apache Tomcat,
JBoss.
Tomcat server. JBoss can be an application server also. That's fine. So now you can say IIS if it is a Microsoft related application. Okay. I mean, if it's a Microsoft related project, they can use IIS web server. Okay. Tomcat web server. So these are the servers where your application is hosted and taken care of. Um, like like generally when you create a website, you guys say that, hey, I'm hosting my website on the server. Where will you host? Right, on these web servers. Okay. Then the same web server will forward the request to application server. Now application server is something like what kind of request can be sent, like a servlet, JSP servlet if it is Java, right? Right. So ADO.NET kind of request if it's a .NET, like that. So application server is where the entire business logic resides. The entire business logic resides. So when you say the entire business logic, what do you mean? Whatever the code that is written by the developer will be will be resided on the application server. So whenever you are running a piece of code, okay, the logic will be running in the backend, right? So that logic will be there in the application server. So the entire business logic will be there in the application server. That's the reason this is also called as business layer. This is also called as business layer. And web server is primarily responsible for hosting the website and also presenting the data on to the client, presenting the data on the client. So it is also called as presentation layer. Okay, this is called presentation layer, this is called business layer, because the entire business logic is resided in this application server. What are the examples of web server?
WebSphere.
WebSphere.
Yeah.
Okay, WebSphere, WebLogic. Okay, like that many are there. Okay, it like it depends on project to project again. Now the same business layer, the same application server, if required, if there is any data dependency to validate or to fetch or to compare, then it will forward that request to database layer, that is database server. So database server is primarily responsible for storing all the application related data. That's the reason this is called database layer. Okay, examples of database server are
MySQL
Oracle,
and
SQL Server. Okay,
yeah,
you can write,
Postgres.
yeah, Postgres, MongoDB, if it's a NoSQL. Okay, like that you can have a lot of database servers as well. So this entire tech stack will be decided by the project architect, and we as a performance tester should know, what is this what type of web server is being used, what is the application server is being used, what is the database server being used. Okay, what are its capacities. Okay, what is the CPU. Okay, what is the max record storing capacity of the database server, like that. Now you tell me, out of these three, which component is more, could be more busy during your load test or during the real time application scenarios. Which components can be more busy in this, or which
Application
components might
server.
be which components might be using more resources and all that stuff, busy and all that stuff.
Application server, I believe.
It, yeah, I mean, database server is also one of the important component. um, but application server is where the entire logic resides and the processing happens. That's the reason uh, there are more chances of getting performance issues in the application server, and then the next is database server. So if you get, like, let's say out of 100, if you get 50 issues from application server, you might get 35 to 40 issues from database server. Remaining 5-10% you might get from the front end browser or the web servers. Okay, no, no, if you think that application server is more important and it is taking more, it is consuming more resources and very important because it is processing all the business logic, it can have some issues, it can run into some issues. That's the reason a single application server instance is may not be enough or sufficient for your applications. Okay, if they think that one application server instance is not enough, then they can add one more application server instance like this. Okay, and then the data will be forwarded to that application server as well. Okay, so there is something called load balancer, which will take care of redirecting the requests, okay, to both the application servers, or if there are three, if there are four, if there are five, it doesn't matter. Load balancer is there is something called load balancer which will take care of the data redirecting or requests redirecting to different servers. Okay, so it has its own algorithm, like round robin algorithm, weighted round robin algorithm, least connection algorithm, weighted least connection algorithm, random algorithm, like that. So we'll discuss those later. But load balancer is something which is redirecting the request to different servers depending on its availability. Okay, now if now some some projects, right, uh, they add additional servers, we call it as scale out, we call it as scale out. in some projects, due to some financial issues or budget issues, instead of adding a new server, they will upgrade the existing servers as well, which is called scale up. Okay, in either way there is every chance that application servers can be increased. Okay, nowadays they are actually managing with multiple servers, because if one server is down, the others will be able to handle. Okay, that's where failover testing is coming into picture. We will discuss in some time. So all in all, we have different components like web server, app server, database server. Okay, you can add as many instances as you want, mostly for the application server, because that's where the business logic resides. Now you might ask, sir, if you are saying 35 to 40% of the database issues can occur, can we can we add database servers? See, the thing is, database servers, um, you need not increase or you need not add database servers extra, but the thing is, you can increase its capacity. Okay, for example, you reach out to Oracle and say that, hey, for my application I need to store at least 1 crore, okay, or 100 million records. Okay, now then they will give you a package which can store that much of capacity, okay, or little more also. Now, due to some increase in the demand, okay, your project data is gonna increase. Maybe it can reach up to 150 million. Okay, then you simply go to Oracle and say, hey, can you increase my storage capacity, the count capacity, record storage capacity to 150 million, like that. So in that way, Oracle can increase its capacity. But what happens generally is, when it is reaching like 1 crore or 100 million or whatever it is, 5 crore, 10 crores, 100 crores, whatever it is, so every application will try to delete some old data, like older than 3 months or older than 6 months, like that, or older than 1 year, like that. So in that way, there will always be some data getting deleted. Okay, and you should not see any issues related to insufficient storage capacity for database. So generally there is no chance of getting such issue of insufficient capacity of storing the data in the database. Generally it won't happen. Okay, so there could be other database issues which we will discuss later, but yes, it is one of the important component where you can find lot of issues. We'll see all those things later. Any questions?
What about the cloud architecture? Like, this is like
Yeah, so
that's
what
the
happens, so what happens in the cloud architecture, these application servers, okay, mostly they will be hosted on cloud, or this stack will be hosted on cloud. Okay, including database. So what will happen in the database, sorry, what will happen in the cloud architecture is, especially in the application server stack, they will have a cloud server instances. Okay, now when we are running a load test, okay, because all the cloud all the cloud concept, they have a saying that, hey, we will provide you 99.999% availability. They won't say 100, but every cloud provider will say, we will give you 99.9999% availability. That means if I am using two server instances of application server in the cloud, okay, like take Azure or GCP or AWS or, okay, uh, PCF, like Pivotal Cloud Foundry, whatever it is. So if there are two or three application server instances in the cloud, and when we are running the load test, if it needs more capacity to handle, if it needs more servers to handle, it will automatically scale out. Okay, there is something called auto scale out, or there is something called like elasticity concept and all that stuff. So basically, in the cloud architecture, your cloud server instances will get automatically added if it is required. If existing server instances are not able to manage the load, then automatically the cloud environment platform will add one more server instance, so that the requests will be redirected to all the four or three or whatever it is, including the new one. So in that way, the load will be reduced on the servers. Okay, so when it is cloud architecture or cloud server, you just need to connect to the cloud environment and see what or how the application servers are behaving. For example, Let me try and show you if it is open. Otherwise, let me see if I can open it. Oh, it's not there. One second. One second, guys. One moment. Okay. So, where am I? One second. Okay. Now, because you asked cloud environment, right? So basically, uh, if you see this, this is a Dynatrace. Okay. Now, if you go to apps here, so if you want to monitor or how, if you want to see how the cloud architecture works, so you can go to, I mean, if your server is hosted on any of these cloud instances, you see GCP, Azure, Pivotal Cloud Foundry, like AWS. Okay, if in fact you can also have Kubernetes, OpenShift containers like that. So if it's a normal on-prem server, okay, we in sense the infra team should be able to add new servers. If it's a cloud where you have the cloud architecture of any of these like Azure, AWS or Cloud Foundry or GCP, whatever it is, those servers will be automatically upgraded. Those servers will
After
be,
scale, right?
yeah, yeah,
Okay.
auto scaled. Yep, auto scaled. So they will be automatically added. Okay. So if it is cloud, you know, no need to worry much. They will be auto scaled and they have that mechanism. Every cloud provider has that mechanism to implement the auto scale out. Okay. So I just wanted to show you more, but because it's since the initial sessions, I just don't want to get deviated now. That's fine. If uh,
Yeah, thank you.
yeah.
Thank you.
Okay. So that's where this architecture is coming from. And I don't forget you have a load balancer in place, which is a kind of software program again, which will use few algorithms to distribute the data load equally across the different server instances. Okay. Now let's say here you have two server instances. This is instance this is one instance, this is another instance. Sometimes you, so in some projects you also call it as node. So this could be node 0, this is could be node 1, like that, because node mostly it will start with 0. So this is node 0, this is node 1. Like this is one instance, this is another instance, like that. So instance and node both are same almost. Okay. So then you have okay. So then you have a protocol. Uh, so protocol in general means, if you go by textbook definition, in general, it means some set of rules, right? So when a client is sending request to server, in order to send the response, first it has to understand what the client is sending. So if in order to understand what the client is sending, okay, uh, so both should communicate, okay, in a common language. Like if two people are talking to each other, both should communicate in a common language to exchange communication, or do some communication. They both should communicate in the same language. Similarly, whatever the client is sending, that's if the server has to understand, it should be in an understandable format. So that's the reason they will follow something called protocols. And protocol is nothing but some set of rules. Okay, client will send the request by following some set of rules. Based on that rules, server will understand what the client is sending and then send the response. Okay. So here you see protocol is nothing but some set of rules. Depending on the kind of communication required between client and server, protocol is selected by the architect. Protocol is selected by the architect. Okay. So depending on the kind of communication required between client and server, protocol is selected by the architect. For example, if you're dealing with web applications, like where you're sending HTTP or HTTPS requests, you use HTTP protocol, HTTPS protocol. If you're dealing with files, transferring between files from client to server, then you use a file transfer protocol. If you're dealing with mails exchange between client and server, then you use simple mail transfer protocol, SMTP. Like that, you have different set of protocols, but it all depends on what is the data that is getting exchanged between client and server. Okay, so based on the data that is getting exchanged, the protocol will be selected by the architect. So before, if you're assigned to some project, okay, the very first thing you do is requirements gathering, right, which we'll discuss tomorrow. So as part of that requirements gathering, you need to ask what is the communication mechanism that is being implemented between the client and server. What protocol is being used? So they will give us the information of which protocol they have implemented and all that stuff. So it's good to gather such information and keep it handy. Okay. So any questions? Okay. Okay. So now let's try and understand the failover testing. Okay, that was pending from yesterday. Now, because we know the meaning of server, application server, and all that stuff, let's try to understand this way. Okay, so there is one, maybe let's say I'll tell you how to do a failover test. It will be easy for you to understand. Let's say this is a load generator machine from where the load is getting triggered. Then let's say you have one application server and you have another application server here. Okay, so here this is server 1, this is server 2, and this is, let's say, load generator machine from where the load is getting generated. Now I told you that there is something called load balancer in between. There is something called load balancer in between. Okay, we call it as LB, load balancer. It has its own algorithm to redirect the data to server 1 and server 2. Okay, in this case. Now, how do you test this? So what is the main goal of failover test? The main goal of failover test is, by any chance in production or in real time, if one of the server is down, the other should be able to manage the load. So keeping that in mind, we as a performance tester are coordinating with the development team or the admin team and testing the same scenario. So for example, you coordinate with developer, say that developer, you can say that tomorrow morning 9 a.m. to 10 a.m. you want to run the test. Okay, 9 a.m. to 10 a.m. you want to run the test. Let's say 9 a.m. to you are on call with developer now or the admin team who has access to bring down or bring up the servers. Okay, I repeat, you are on call with the developer or admin team who has access to bring down or bring up the server. So 9 a.m. to 9:15, let's say 9 a.m. to 9:15 a.m. you ask the developer to don't do anything, ask the developer not to do anything, just run the test. So all the requests will go here and load balancer will equally distribute the load like this. Based on some algorithm, load balancer will equally distribute the load like this. Okay, from 9 a.m. to 9:15 a.m. Okay, now from 9:15 a.m. ask the developer, okay, ask the developer to bring down, let's say, server 2. That means at 9:15 server 2 will be down because developer intentionally brought down the server 2, okay, 9:15, and then from 9:15 to 9:30 we are running the test again. So here what is happening, again so many requests are coming to load balancer. Now load balancer has the capability to know that server 2 is down. Within how much time it will come to know? Hardly in like 1 or 2 seconds it will come to know that the server 2 is down. It has that capability to know. Now when it knows, or when it has the capability to know that server 2 is down, or when it already knows that server 2 is down, what it will do is it will redirect, it will route all the requests to server 1. It will route all the requests to server 1. It will route all the requests to server 1. Now, now in this case, what we are exactly checking here from 9:15 to 9:30, we are checking if server 1 is able to manage the entire load, how is it performing, okay, how is it performing, is it able to withstand the load for the 15 minutes duration, because all the requests are now getting redirected to server 1. Is there any impact on the response times, okay, because when two servers are up and running, the load will be distributed equally, and because there is less load on each of the machines, both of them will process very fast. Now because this is the only one which is managing, it might have a direct impact on the response times. So we from 9:15 to 9:30 we continuously monitor the server 1 performance, the response times we are getting, the memory utilization, CPU utilization, if there is any crash, if there is any server restart, all these things we monitor from 9:15 to 9:30 for server 1. Okay, then at 9:30 we ask the developer to bring this server 2 back to normal. We ask the developer to bring this back to normal, okay, and bring this down. Now we are now from 9:30 to 9:45, okay, 9:30 to 9:45, 9:45 server 1 will be down, server 1 will be down, and we are checking whether server 2 is now able to take the complete load, okay. How is it performing, what is the CPU and memory utilization of server 2, what are the response times we are getting for that duration, all that stuff we will be checking for server 2. And at 9:45 we ask the developer to bring both these servers to back to normal, up and running. In this case we verify, because both are up and running. Again, the load balancer has the capability to know that both are up and running, so immediately it will again start redirecting the load equally based on its own algorithm, like round robin, weighted round robin, least connection, or weighted least connection. Okay, and now from 9:45 to 10 a.m. all the load should be equally distributed from between server 1 and server 2. Okay, in this way we coordinate with developer and do this kind of failover testing. Any questions?
For the AWS architecture, right, when we are doing this failover test, so we put one region down or like east or west, right? Or any instances in that region we put down.
um,
Like we ask.
yeah, it can depend on what they are offering as a cloud provider. So a region can have a multiple server instances, obviously. So if you want to test within a specific region, yes, you can do that. Within a specific region, you can have multiple server instances, and you can test that. And if you want to coordinate with the cloud provider and see, you know, you can bring down the whole region and see whether the other region is able to manage entirely, you know, for the rest of the duration, is what you can check. So it's a simple task, nothing change. We are connecting with developer here in this case. If it is on prem, obviously if it is cloud, we will reach out to cloud provider support team, and they will guide us whether they can have a separate region, or they can bring down the entire region and keep up the other region, you know, up and running. Okay, or within
Mhm.
the same region, can they bring down some of the server instances? Yes, but as per me, both are possible for sure.
Okay, based on the request,
Yeah,
right?
based on your request they will support you. Yeah, it should be, you should, yeah, it should be your requirement, like which region you want to bring down, or which server instances you want to bring down. So you can have multiple test cases for that, multiple scenarios for that, like bring down server instances within the same region, or bring down the whole region. Like 15 minutes you can, switch between those scenarios and see.
Okay, okay,
Yeah,
got it.
but good thing is you need I mean, first thing is you need to coordinate with the cloud support team for sure.
Okay.
Okay, because they will have the access to bring these servers down.
Okay,
And where
thank you.
this LB reside actually? I mean, at
It
which
it can be, yeah, it
server?
can be anywhere in the architecture, like before web server or after web server, or within the web server instance also it can be there. It can be there in the, like, it can be there in the within, it can be there in the web server, machine server itself, server configuration itself. They can add this, they can run this load balancer algorithm. Okay, so as and when the web server receive the request, the load balancer will get activated, and it can forward the request to application servers accordingly. So anywhere they can place it, it's just a program which runs some algorithm, that's it. So they can place anywhere where they want, depending on their requirement, but basically it will go along with the web server. Okay, so yeah, I'll give you a 20 minutes back today. So I just don't want to start a new topic, but the next topic is, when you get um, when you get a project to work on performance testing, what exactly you do, where exactly you begin your work. Okay, what are the different questions that we need to ask to the application team or the stakeholders before you start working on any project. So how many questions you need, okay, how many things you need to ask. So this is one of the important interview question also. The important interview question is, so before you start working on any project, what exactly you do, and what exactly you do as part of your questionnaire, questionnaire preparation, what type of questions you ask. So in this will be asked mostly by leads or managers. So uh, I mean, the question is that important that if you answer it quickly, like, even if you tell like 7, 8, 9, 10 questions that you might ask to the application team, your interview is almost like 20-25% on the positive side. So okay, so it's that important. So let's discuss in detail tomorrow. I have my own questionnaire template, which I will share, and we will discuss all the questions, and what are the different, what type of answers they might provide, and how should you plan your entire release. So let's discuss tomorrow. And also we'll discuss what if client is not providing you enough data. Okay, what if client is not aware of performance testing. All these things as well we will discuss tomorrow. Okay, so I'm stopping the recording here for now.